Well, I think we're going to go ahead and get started. Can everybody hear me okay? Hello?
Hello?
Everybody can everybody hear me okay?
Yeah.
All right, let's go ahead and get started. In this session, hopefully this is just the first of many to come. I want to talk about Angular JS framework. My name is Sergey Barsky. I work for LGD division out of Duluth/Atlanta office. And in this session, I'm going to try to do a high-level introduction with some small amount of coding to Angular JS framework. What is Angular? So the first quote that you see comes from the actual web page or home page of the framework. It was written and being maintained actively by people who work for Google. And if you look at the project website, you'll see there is a handful of people there who are primary project maintenance team, but they do accept contribution from other people as well. Currently, it's in version 1.0 or so, with version 1.2 being on the release candidate stage. Primarily, what is Angular? So it's a framework for building web applications that provide some level of separation of concerns between various components. It is primarily there to build single-page applications or SPAs. What that means is that the entire application or large parts of it are downloaded when you hit the page, the home page of the application, and from that point on, all communication with the server consists primarily of data exchange, but no UI. So the idea is that you upload all of your JavaScript in one swoop, unless the application is so big that it's simply not feasible. And then as you navigate from page to page, Angular will fill in the gaps in your UI by downloading any data that is needed and any HTML templates, which is just another word for user interface. The reason they have MVW there in the name, W actually stands for whatever. So primary moving parts of Angular are M and V, and nobody can reasonably name whatever that last letter is. M, of course, stands for model or business model, which takes shape of plain JavaScript objects. Vue, of course, is the HTML, which is the language of the web. And into this star, you have some number of components. My opinion is that controller and scope objects both sort of form that last letter, whether you call it C for controller or VM for view model. It really is one and the same. The idea is that you have some glue that puts together your view and your model, a built-in user interface with the data. One of the main advantages over traditional web apps is how the components are separated. Angular sort of leads you toward the way to follow their patterns in the separation. In other words, is when you write your JavaScript code, that code falls into a few main groups. And although you can cross the lines between the groups, it's a little bit harder, although not impossible. The idea is that if you write view-related code, in other words, code that manipulates the DOM, it needs to be in a certain place as far as components go. If you write components that save and get the data from the server, there is a specific name for those. And that separation of concerns leads to a better testability as a result, where you can maybe fake some other components such as web server interaction and still be able to test your controllers. And we'll see an example of that in a few minutes. One thing that I talk about typically is how does it relate to XAML and MVVM pattern. One of the reasons is a lot of developers, at least at Energov, done a lot of Silverlight, and I think it helps, if you come in from that world, it helps sort of frame the Angular as not really the alternative to MVVM pattern, but more of a parallel. When you look at MVVM, typically you'll have your business objects or the model. In Angular, that relates to plain old JavaScript objects. Your view is XAML in XAML-based apps, and of course, in Angular, it's HTML. A view model in XAML apps, that typically a custom object that is responsible in some way for getting the data and exposing the model to the view. In case of Angular, controller in conjunction with scope plays exact same role. Controller's role is to interact with the server through another, hopefully, abstraction layer and expose the models to the views, as well as provide functions, in other words, actions in XAML world that will be fired as user performs actions on the view, such as clicking buttons. Yeah. As we look at the high-level features of Angular, number one in my mind is two-way data binding. In a sense, it is similar to two-way data binding in XAML, although in Silverlight/WPF apps, that type of code belongs way deep in .NET framework itself, whereas in Angular, that is specifically written JavaScript library that performs that function because that specific function is not built into the browser itself, which would have been probably much nicer and more performant. The way two-way data binding works in Angular is by observing the browser. And it's done in what's called a digest loop. So at specific interesting points in your application lifecycle, Angular will wake up, it will examine the DOM and your model, and it will synchronize the changes. So if a user typed a key into a text box, that digest loop will push the data into the model. If a controller through a service called a web server and got some data, that will also wake up digest loop, and it will make an assumption that something has changed and it's time to synchronize the model with the view by pushing changes into DOM. So at a high level, it seems like a very simple concept, but if you examine the user interaction with a typical website or a web application, you will notice that that digest loop only needs to kick in at very specific points in time or in the life cycle. That would be AJAX call, a user interaction, whether they pick a value from a select or type something. And those typically are the main reasons why digest loops will wake up. Another more of a side reason is the timeout functionality that will fire periodic basis. And because Angular is observing that as well, it will wake up and run the digest loop. That's the way you think about it. It synchronizes the model with the view. Because it does so much work, it has some performance limitations. And in the book, the guideline that is mentioned is after about 2,000 bindings per visible DOM structure, you will notice a lag. In other words, user types in a letter, and it takes some visible period of time before your model is updated. So the recommendation is to keep your number of bindings to a reasonable number. So you don't want to build an extremely large page because it will not function well. And even if it may function properly on the desktop, if your app is also mobile friendly, it may flake out much earlier on the phone. And so the idea is don't build large apps. If you compare to Knockout, and I know some of our people at least use Knockout, which is a different MV star framework for JavaScript, they do it slightly differently. So it's a little bit more efficient in the way it handles data bindings because they create this observable, very specific classes that listen to both a specific DOM element as well as specific model element and keep those in sync. And you will have this an observable object per model property per DOM element. So in a sense, it's a little bit more efficient, but if you think a little bit more broadly, you will see that Knockout may be subject to exact same problems if you build large pages because it still has to do a lot of work. And if you have a lot of code-dependent properties, you will see that your update loop, or there is technically no update loop, but update function may also take some period of time. And Knockout has other quirks that may cause some performance degradation, such as building large tables. So if you use if you show thousands and thousands of rows of data in a web page before, you will find with either Angular or Knockout, you won't be able to do that because your web page will be non-responsive. So keep the bottom line is to keep your data to a reasonable minimum. Another high-level feature is the templating, and most JavaScript frameworks have some variation of that. And what I mean by that is that the view is built dynamically, either based on user navigation or data binding. So you can write code that will loop, for example, through an array, and you give it an individual item template, and it will replicate that template for each item in an array. So that's how you would build, for example, a tabular data in both Knockout and Angular. So they both have a repeat type binding, which is similar to a repeater in a way in ASP.NET. Another big feature is routing. What you would do in a SPI app, you would define a route. And a route essentially is keyed off the browser URL. And in addition to that URL, it will have some properties such as what controller is going to be handling that specific URL and what view is going to be shown. So you see this MVVM pattern is coming back again. I'm talking about the controller, which will expose the model to the view, and both controller and the view are part of the same route. Having said that, routing is not only extensible, but it's also really puts the URL itself into focus. And what that means is that you can, even though it's a SPI app and you think of it as dynamic application, if you email somebody a URL, they should be able to click on it and have that SPI app download all the components and automatically navigate to exact same page you were looking at. So it would be a mistake not to put your URLs into foreground of the process, because not only they need to be unique, but they need to be hopefully descriptive as to what your application is doing. but each route is defined by its URL. As it relates to routing, there is one slight problem I want to mention, which is search engines. So because typically a search engine or a crawler will crawl through your site, clicking on links, following the links, and building this metadata repository. Unfortunately, right now, none of the crawling engines know how to handle JavaScript. And because the Spy app is JavaScript based, they won't be able to legitimately go through it and create some kind of a metadata that is searchable. So as it relates to that, you have to either jump through some hoops yourself, or you can deploy third-party products that popping up because spas take hold in the development community that will do the search engine handling themselves for you. So you would give them a URL. They will use, instead of a crawler, they'll use what's called a headless browser. In other words, a browser without a user interface, such as Phantom. They will load your site into Phantom browser. Then they will output HTML. And when a crawler asks for your site, you redirect them to that search engine site. They will return parsed HTML that is totally digestible by search engines. So that's a little side note on routing. The next big feature is dependency injection. And in .NET community, pretty much everybody heard of it. In JavaScript world, it's a little bit more convoluted. The reason is that in .NET world, you have a type system. So somebody can ask for an interface and you can return a concrete object. And that's how you would handle most of dependency injection. In JavaScript world, not that there are no interfaces, but the type system really doesn't exist as such. There are some types, but there are definitely no classes. So you have a problem there. Angular takes a very interesting approach to solving that problem, and their dependency injection is based on names or strings. So as you define an object literal, for example, you tie it to a string, and anytime you need to inject something, you inject a string into a specific place, we'll see in a minute, and as a result, when your class, well, class is a loose term, when your object is resolved and created through this factory function in Angular, it will look at the strings you specified as your required dependencies, and it will inject corresponding services into your object's constructor. So that's how a dependency injection works in Angular. What it buys you is loosely coupled application that is highly testable, because you don't declare dependencies explicitly. Instead, they're more implicit through dependency injection engine. And the last high-level feature is also quite familiar to MVVM XAML developers, which is modularity. What that means is that you can group your components into logical modules, and you can load that module as a single entity, which will bring all the related components into play. At a high level, I'm not describing every singular component that Angular has, but I'm concentrating on things you would write on a daily basis. That's why conceptually there are only 4 things that you would typically touch every day. You will write obviously other things, but those will be few and far between, whereas you would write directives, filters, controllers, and services on a daily basis for sure. Hence, let's go through those and take a look at to see what each one does. Directives are designed to manipulate your DOM. That should be their sole purpose. That is not to say you cannot have them read your data. That's completely legal and completely possible. But what you don't want to put into your directives is maybe database calls to your server or some business logic. That's not what they're for. And typically what you would do in there is either build up a DOM, maybe handle DOM events, or do anything else DOM related. Filters are similar to converters in XAML in a sense. In other words, they sit inside the data binding layer and they translate data that's coming from your model into your view. So you can think of it as an interception layer between a model and a view. So a model can have a first name property, for example, but in the view you want to show it in uppercase. That's when you would inject a filter. And a filter is the one that's going to do the uppercasing because, again, this is a presentation construct. Filters can do a lot more than just that type of a simplistic data manipulation. They could serve as filters on arrays as well. So you can specify a filter condition, and then inside your, for example, table loop that loops through an array, you can only filter items in an array that fall into that specific filter condition and build UI only for those items. Controllers is really a glue that puts views and models together. In a typical controller, you would create properties that go into your scope. And scope is really what is data bound to a view, not raw properties that sit inside controller, but specifically only things you want to expose to a UI. And what I'm trying to relay here is that if you have some property that controller needs to maintain some state, you really don't have to put that into the scope because, as I mentioned before, data bindings, number of data bindings is one of the key limitations of Angular. So you only want to expose to UI through the scope, only the things that absolutely need to be visible to the user. Everything else should exist in a controller on its own. Finally, there is a way for you to create services. And you think of it in a bit broader scope than just HTTP service to get the data. There are many, many other services, quote unquote, you can provide. They don't necessarily deal with data. Maybe you have a service that provides a message box that you can use everywhere. Or maybe you have a service that does some parsing or something like that. So think of services as a little bit more broader of a concept than just data. Now I'm going to kind of at a high level mention one of the key components that, again, built into Angular, but typically fall into these four broad categories with some additional information. There are directives that built into Angular that are very, very important. Number one, you need ng-app directive. And ng-app is really a Bootstrapper directive. So it serves a similar purpose as if you were to use Prism with your WPF or Silverlight app. Typically, there is a concept of a Bootstrapper in that app. ng-app is the exact same thing. In other words, you would specify the top-level object, which typically is a module, and you would specify this top-level module just like you would do in MVVM that would do bootstrapping of your app. In other words, wiring up all the components. ngView is a routing concept, and it's very similar again to some area that you would have in MVVM apps where you would place your views as user navigates through the menu. Like almost identical concept is done by ngView directive. And you would create typically an empty div in your home page in Angular app, and you would put ngView directive on it, and then as you navigate through routing system, it will look in your route definition, find the appropriate view template, and then we'll shove it inside the div that is decorated with ngView directive. Controller is another important one. You really don't have to use them as if you use a routing system exclusively, because your controller will be automatically assigned by the routing system. But if you want to have multiple controllers, you can use multiple ng controller directives. So inside your view, for example, you don't have to have just a single controller. You can have 3 or 4 of them. Each one is responsible for a certain part of that view, and then you will need to use ng controller directive to wire up a controller, as I mentioned, to a subset of that view. The next one, which is the binding directive, you will use all the time. And what that means is that on your DOM element, you specify ng model, and DOM element would typically be an input control or a select control or a text area, one of those input elements in the DOM, and you would bind a model to a property, excuse me, to a property on your scope, which, if you remember, scope is something that encompasses your business model. So by the sheer fact of specifying ng model directive with the name of the property, you will wire up automatically data bindings. One thing I didn't mention what directives are. Typically, directives are simply attributes you put on the element. So if you look at ng model directive, if you put it on input control, it's simply going to be an attribute called ng-model or data-ng-model. And inside of that attribute, you will specify a string that's going to be automatically parsed by Angular. And of course, there are directives or services at a high level that are built into Angular that replace raw DOM events and objects. And the reason for that is that you can not only be abstracted from the DOM and idiosyncrasies between browsers, but you can also, in some cases, fake those services. For example, you can fake out AJAX calls. And the reason for that is that you're not using raw browser XML HTTP request. Instead, you're using a service. The same would apply, for example, to a Windows service in Angular. So instead of calling window.whatever, you would call the Angular service that represents window. And with that, you have more flexibility than you typically would by talking to DOM directly. Here's some of the services. When it comes to services, all Angular services are prefixed with a $sign. And when you write your own app, then don't follow that convention because it becomes kind of confusing. So don't name your services with $sign. But all Angular ones are with that. HTTP, which is simply an abstraction on top of XML HTTP request, or in general, any HTTP request. That's a $HTTP, and as you would guess, it would have methods like get and post and put and delete, which is what you would expect. There is built-in caching provider, which is a $cache service, and that one could be used to cache to cache some of your data for further use. As always, you gotta use caching with some caution because that is the memory inside the browser. So if you overdo it a little bit, you might run into problems. As I mentioned before, document is another abstraction on top of DOM, and so is $window and $location. You see the theme here. They have exact same names as the DOM services, but they just have a $sign prefix. And in an ideal world, which will hopefully we'll all live in, we would never want to refer to a window itself or location or a document in our code. Instead, use $whatever corresponding name. Value parser is the service that does a lot of work when it comes to data binding. As you imagine, if you look at data-ng-model and you set it to user.lastname, that user.lastname is obviously just a string. And a parser service is one of those key components that figures out what that means to facilitate the data binding, but also you can use it as a standalone, for example, in your directives, and parse the attribute value with $parse and get the actual value from the model versus just a string. There is an implementation of promises. So promises is simply an object, in a sense, that typically has success and failure handlers. And promises are used pretty much everywhere in Angular. Even if you don't use Angular, in a sense, you always deal with promises, whether you like it or not. And when you make a call to a service, you don't know if that's going to work or not. And the return value from the call, which is asynchronous, is simply a promise. And when the call actually completes, the promise is going to be resolved. If you look at .NET for an analogous concept, what you will find is task API. And when your method returns task of string, for example, because it calls HTTP client and downloads some string from a server, in a sense, task is very analogous to promise in Angular. And in a lot of web apps, they have their own promise implementation. But if you want to think of it in terms of .NET, I would think of it in terms of a task, with a slight difference where you would, instead of wrapping a task inside try catch for a failure, instead you would subscribe is a loose term, subscribe to a success or failure events on a promise. Scope, as I mentioned before, is that glue between a view and the model, and in Angular there is a concept of root scope. And root scope is not something that you would want to use typically, even though you can put your values onto it, but not only it's confusing, but it would be akin to global variables, which you really want to avoid because those things really don't work as well. But scoping is an interesting animal because it works very, very similar to data context inside XAML application. And one of the key things for that is that it flows down in a sense. So it cascades. So if you have some property on a scope, and then you would create a child scope off of that, and inside the child scope that is bound to some view, you would access property that exists at root scope. It will actually resolve. It's not something you ever want to use, but it's important to understand that the scope is flowing down the DOM. That's the best way to think about it, with the $root scope being at the peak or at the very top of that DOM. And in addition to that, certain directives also create subscopes or child scopes. An example would be a repeater or ng repeat directive that would create UI for an array. You would create a child scope for each item in an array. And that's would be an easy problem to run into actually if you're new to Angular, because if you put a button on that one item and you try to invoke a method on a parent scope, not on each item scope, but on the scope that has the array used to build that table-based UI, you will find your button won't fire. And that's because the scope you're in is not the same one as the parent scope. There's a whole slew of helper methods there that do just certain useful things that you run into often. And I mentioned just like a few of them, and they typically test or do some minor things on your objects. And you see these are some of the examples. So now it's good to listen, but I think a lot of things become much more clear if you look at the actual code. And what I want to do is jump back to a slide where I had some of my key components listed, and let's write one of each, because these four things you will always use. So first thing we want to do is create our Bootstrapper module. What you would do, you would call a module method on the Angular itself, and this one takes module name, so I can just call mine app. And then it takes an array of dependencies. And after I've done that, now I can bootstrap my app, data-ng app, and I give it my module name. So this app and this app are the same. So let me rename it, because app is sort of a confusing term. So now if I refresh the browser, nothing will actually work, but I should not have any exceptions. So let me drag this a little bit over, make some room, and we can see both browser and the browser tools window. And if I look at console, no errors. Typically, if you did something wrong, you would immediately see some errors. So this doesn't do really anything useful quite yet, but now application is bootstrapped. Now let's write something different. So let's write a controller. So in this case, again, the theme, as you will see, is very similar. I need a name, and I'm just going to call this one home. And then I need dependencies. So for now, I'm going to leave the dependencies blank. And now I can use Fluent API, which means you can chain methods here to create certain things. And what I want to do is create a controller. And here I need to provide a name. As far as second parameter is concerned, what you will often see in demos return something else. Doesn't matter, something like this. You will see this. And the problem with this approach is the dependencies. So for example, say I have a dependency on HTTP. And I can take HTTP as a parameter to my controller. So this will work fine in a simple demo, but as soon as you minimize your JavaScript, chances are this $HTTP is going to be renamed to A or B or C, and then your code is going to break, because the dependency injection in Angular works based on names, as I mentioned. So this is not the syntax we want to follow. So there is a different syntax we do want to follow, and this syntax allows you to declare dependencies here, and I'm just going to declare one, I'll delete it later. And the last parameter in this syntax is always something that returns controller. And all I need to do is create it inside my function. So I can use object literal, but I'm just going to use function. And the reason for that is because I want to accept parameters. And then I want to return the instance of that function. And I want to inject my HTTP into it. So this is, it's a little bit of a weird syntax, but what you will see that almost every component follows this exact pattern. So once you get the pattern right, it will become very, very easy to read and understand it. And so what I'm doing here, I'm declaring a name, then I'm doing the way to think about it, sort of an array of dependencies with the last parameter or the last item in that array is the creator function. So now I have created my home controller. Now I can wire it up, and I'm just going to put it on the body. Now when it comes to directives, you can use two types of syntax. So I can use ng controller, or I can use data-ng controller. And data-attributes are parts of HTML standard, obviously, which is something that browser simply just ignores. And ng controller is obviously not. So if I were to delete dash in a UI such as Studio, I will get a warning saying, hey, you're using an attribute that is not known to HTML5 or even 4 standards. As I mentioned before, all injection is done based on name. So even though that doesn't look like injection, but in a sense it is, because I'm injecting a home controller inside my view. So let's see how many errors I'm going to get now. I should get at least one. And what it says that Angular does have no idea what home controller is. And here's where you need to declare dependencies between modules. Our bootstrapping module is main, but it doesn't know anything about home module because I didn't tell it to. So here's how we resolve dependencies. Again, think of it as dependency injection, where names are important. So even though they're strings, but they actually are key to wiring up Angular stuff. So now the error went away, meaning that my home controller is successfully created and it's injected into a DOM element. Now let's refactor this code. As I mentioned before, something that you always use is the scope, because otherwise there is really no reason to have a controller, and I gotta rename them all, and no reason to have a controller unless you expose something to the DOM. So let's expose something to the DOM. We can say $scope dot, and we're just gonna create a person object. And this is just simply going to be an object literal, and I'm going to say last name, we're going to assign, I'm just going to use, I'm not that vain, so I'm just going to use John Doe here. First name, I don't know, whatever. So now we have our scope. So the only thing that I did in here is I created a new property on a scope object. I called it person, and that specific object literal has two properties on its own called last name and first name. So far, that's really all I have done. Because I don't want to get too far away from any potential errors, I'm going to flip back right quick. make sure nothing blew up. Now I need to expose that to my view. So let's start with an input control. It's going to be a text. And here's where my model comes in. And guess what needs to be here? So I already mentioned that it needs to be a property on a scope. So you never type a scope into your model because scope is something that is sort of transparent and it serves as the root for all properties. Instead, I will type person dot last name. That's all I've done. So let's refresh, fix the errors, and move on. So that so far worked. A sort of a shocker, really. So let's recap what we've done here. We totally separated our UI from our business model. So this is my business model, which is a person. Here's my UI. The only way I'm wiring things up is through data binding. So nowhere in here you would see code such as something like this, $, pound, last name, dot val, whatever, person dot last name, yeah, whatever, LN. So here's the code you're trying to avoid. You're trying to avoid the code in your controller that touches DOM. And the reason I'm able to do that is through data binding. So now let's see how data binding works outside of the inputs. So for example, in a span, I would like to show the same last name. If you work with some other framework such as a master, something like that, you've seen the double curly braces. Yeah, last name. It's important not to make any typos. So if I've done everything right, I should see a span right next to my input with the exact same value. But see what happens now. As I type, my value updates. So that's the digest loop and two-way data binding in action. As I alter the data, my model is immediately updated. Not only that, but anything else bound to my model elsewhere in DOM is also updated. So that's what digest loop does. So if I were to put like 1,000 text boxes and spans on this page, you would see a visible lag as I type because there is a lot of work that happens here. So make sure you don't go crazy on large screens. The approach that Angular team recommends is that you use modules as sort of the natural groups of functionality. So let's write a filter because filter is sort of easy. If you write in something common, I would recommend that you would create a module for common functionality. So I'll create common. Instead of a controller, let's create the next stereotype object in Angular. So let's create an uppercase filter. Uppercase. I'll just call it uppercase. And I really don't need scope in here, so I'm going to delete the dependency injection because I really don't need scope. I could inject stuff in here, but in my case, I really don't need it. So let's create an uppercase filter. It's really, really simple. It's a function. And I'm going to say if input return input to uppercase, otherwise return input. So it's really simple. And then I'm returning the filter. Because you have a body to write stuff in, you have a little bit more flexibility how you define your code. So you don't have to write it all in line. As a matter of fact, I could declare filter even outside the module. Not that it's a good idea, but I could have. So now that the filter is written, now we need to use the filter. And you use the filter by piping, which is, again, quite familiar concept, by piping the input through the filter on the way to the view. So if you read this line, what it says is, when I'm building the span, take person.lastName, pipe it through the filter, and whatever filter outputs, then replace this double squiggly brackets with that output. So let's see how many mistakes we made here. Okay, so again, it's a dependency injection problem, as Saeed tells me, and what I need to do is declare a dependency on common in my Bootstrapper. So let's refresh this. So now the filter works. And what is interesting again, that as I type, it still works. So it doesn't have to be this simple, obviously. You can do a whole bunch of things, but the idea of filter is very, very simple. You take some input, you transform it the way you see fit, and then you return it back out. So now let's write a service. Let's just add it to the same home controller. And you see I can chain my methods here. Again, we have a name. I usually just type that right away in, and then I type in a function so I don't forget. And then I'll go and fill in the gaps. So that's how I typically type. That way you don't forget the signature. And as you notice, signature is always the same. First is the name, and we're going to call it home service. Then the dependency. So let's use HTTP here. Built-in Angular HTTP service, and whatever you declare as an injectable inside the array function, you need to pass it in as a parameter. So in here we can say service, which is going to be, again, you can use a function or an object literal, doesn't really matter. Return new service. And of course, since it takes HTTP, we need to pass it back in. And on the service, I simply just need to create some method to call HTTP. So I can say this dot get data would be $HTTP, which is my service, dot get, and I have a text file. And then, as I mentioned before, all methods on $HTTP service or just HTTP service, they return promises. So I have success, which takes a function, which takes data, really takes more parameters, but data is the only thing I'm really interested in. And I have error, which also takes function. This takes a lot more parameters. It still has data, it has status, it has headers, and it has config. Config is an interesting concept, unique to HTTP service. And what it does, it allows you to pass parameters from get into the handler. So I could do this. I could say, do some object literal and say, my setting true, just an object literal. And in here, in a handler, I could do the same thing. I could say config.mySetting and do some checking. So that's the idea of config. It's a pretty powerful way, and it's really similar to async state parameter in .NET. Typically, if you have an async call, whether you build WCF async proxy or something like that, there is always parameter called user state. So this config is sort of, in a way, a user state. And whatever you want to do here doesn't matter. Essentially, we just want to handle the error. So that's what we have now. And to use my own services, I use them, interestingly enough, in the exact same way I use somebody else's services. They become injectables all the way around. And I'm not sure where to call it, but we're coming up to the end of it, so I'm going to skip to a pre-built demo here. So scope.onGetData would be a function, and this is where you would call the service. So it would say home service dot get data, and I'm going to cut these things out for a minute. And paste them in here. So this is how it would look. So your service returns HTTP. You obviously can put error handling in here, or you can put it in here. In a success, you typically would do this. You would say $scope dot some other property equal data. So this would be your typical code. As you call the service, you don't want to write, again, you don't want to write this, $pound blah dot val data. So this is what doesn't follow the spirit of Angular. Instead, you always assign whatever it is you got to the scope to expose it to UI. So let me switch to a pre-built demo because it's almost 12 o'clock. And here's the service that I mentioned. It's identical code. Scope.getData is a function. And to invoke it, we use data-ng click directive. An ng click is simply a universal click event that's going to be intercepted. And as this event is intercepted by Angular, it's going to parse out the function you specified inside directive, and it will invoke that function on the scope that is bound, that is used to build this UI, in which in our case, it's a scope on the home controller. And the only thing I ran out of time to show you is this directive code. And as I mentioned, directive is DOM code. And this is where it's perfectly legal to use the $sign to access elements and do all kind of other things. So, again, there is an abstraction for jQuery in Angular as well. So instead of $whatever, you would write element whatever, or more specifically, angular.element. In my case, I don't need to write angular.element, which I could do like this. So I can say var button equal angular.element. And in here, I could do pound button. So this is a jQuery replacement, although Angular ships with jQuery Lite. So certain methods that you would expect work just like jQuery, they may not. So if you need full jQuery, you need to be aware that not everything that is in jQuery is in JQLite inside Angular. But most things are, like queries such as, or selectors, they're all in it. Animations are in it. Some DOM manipulations such as ATTR, val, CSS, those typical, very heavily used jQuery methods, they are all in it. So in this case, I'm adding a directive onto some element, and when a directive is wired up or bootstrapped, my link function is going to be invoked. So if your directive doesn't do heavy DOM replacement, link function is what you would use. There is also other function like compile that allows you to completely restructure DOM and just wipe out things and replace them with things. You obviously can do it with a link, but that's not what you would typically do. And when link is invoked, the scope is passed in, and again, scope, as you remember, cascades down. So whatever the nearest scope is, it's what's going to be passed in. Element is angular.element or jQuery object that is wrapped around the actual DOM element that the directive is on. So if we find this directive right here, it sits on this button element. So button element is what's going to be passed in here. Attributes is going to be any attributes on that DOM element. So I will get all this in there. I will get the class and ngClick and everything else. And if you implement your own directive, typically you would invent your own attribute. So in this case, this is a main directive attribute, but my directive also is doing something extra. So to pass this extra information into the directive, I use additional attribute called data-class, and you will see that I'm grabbing it here. One thing you notice in all the directives is that the names are what's called normalized. In other words, the name of your directive is going to be parsed on uppercase letters. So if I parse this on uppercase letter, I would get add space on space click. Then everything is lowercase, and then dashes are inserted before uppercase letters. So add on click got translated into add dash small on dash click. Data dash is optional. I typically just always use it, so I don't get validation errors in Visual Studio. So the directive, again, is something that manipulates DOM. I think it's 12 o'clock on the dot, so that brings our session to its conclusion. I'm not sure if there is any value in sharing this code, but I don't mind, so I could share the code as well as the videos. I will just need to find some place to put it on. My personal hope is that we will continue this type of occasional discussion on technologies and sort of help each other learn. The idea is that if somebody does many, many hours of research and then they can compress it into 1 hour, relate to everybody else, I think we all benefit for those types of presentations. So if you'd like to talk on something, please, I'm not sure if you want to email me. I sort of would like to keep it as democracy, but I will coordinate. So if you want to talk on something, just email me, and I will give me some date and time, and I will arrange the meeting and invite people and do some organizational legwork. So hopefully you guys learned something. I don't think I have everybody's email address, so I will email the same group of like technical leads that initially disseminated this information with a link, and then I can relay the link to the video to the rest of you guys. But please email me if you're interested in these types of session. I will create some kind of a distribution list, and hopefully we can keep this dialogue going. I think that's really all I have. So I'm going to, everybody's unmuted anyway. So if you have any questions, go ahead and ask. And if not, we're done.
When you're binding it to, like you bound it to the input over the ng model, it automatically bound to its text property, right? Can you change it?
Yeah, so the question is, what does ng model bind to? And ng model, which is right here, binds to a default property, whatever Angular theme deemed as default, which would be the text property on input control, and it would be check property on a checkbox and so forth. You can write your own directive to do whatever, but ng model binds to a default property. In that sense, it is different from Knockout, where for each property you have to actually specify what it is you bind to. I like Angular approach better because to me Knockout seems like they kind of squish unrelated things into one string. I always felt it feels a little dirty. In here you would create two directives if you want to bind to two things. And most common things you'd want to do, you do with Knockout are already there. So there is a ng hide directive. So if that evaluates to Boolean, it will be hidden. There is ng show. If it evaluates to Boolean, it will be shown. So there's a whole bunch of enable, disable. There are those directives. Whatever Angular doesn't have, you can write your own to do whatever. All common ones you won't have to write.
Is Angular data validation? And could you like validation of the raw values before you apply like a filter to it?
So the question is if Angular supports validation, and it does. And the philosophy is that you will write validation directives that would sit there in close to data binding layer, and then you would set a validity on a property. So that leads to a whole big discussion, which we'll probably need to postpone until the next time, because data validation is probably an hour-long talk in Angular as well. At a high level, it'll be directives that would do some basic validation, such as required directive, which incidentally also already exists. You don't have to write simple things like that, like there's required directive, there's max line directive. Some common things are already written, but they work in conjunction with form and form controls. So when you bind a scope to a form through a controller, Angular will create what's called a form controller. And then for each field, it will create a model controller. And the validity will be maintained in those controllers. So your directive would set a validity on that controller, and then the controller has a valid property, and you would bind your error message in some way to that validity through like ng show directive, so it will only pop up when it's invalid. So that's at a high level how you would do validation. Yes, you can keep piping filters. So the question is, can you use multiple filters? Yeah, you can pipe multiple filters. They'll all be piped one through another. I think that's it. Thank you.